Hello, everybody. So this is tonight's screencast. It is on plate tectonics. I will try to make it brief. So the theory of plate tectonics basically just means that you have these plates. There are 7 main ones. There are a couple smaller ones, and they float around on the asthenosphere, which is the ooey gooey layer. Okay? There's evidence for this theory, the jigsaw puzzle of all the continents, how they fit together, and then there's also fossil and geologic evidence. Okay, so here you see your plates are up here. They move around on the ooey gooey layer of the asthenosphere. As you can see here, you have Pangaea, Laurasia, Gondwana land, and this is present day right here. And you can see it looks like Africa right here used to fit in perfectly with South America here. Another thing is fossil and or geologic evidence. So in South America, you find this Cygnognathus dinosaur in this whole range right here. Now, if we were to look at the map the way it is now, Africa and South America are separated by a massive ocean, which means that at one point in time, we're figuring this is evidence that they were actually together. Same thing happens for matching folded mountains, coal deposits, glacial deposits, and you can see, okay, you have this red here and you have this red here. And this is evidence for this theory. Plate boundaries. We have 3 different types of plate boundaries. Okay. Faults are created where these rocks fracture and slip past each other. Usually there are earthquakes here. And there was just an earthquake in San Francisco, actually. A couple days ago, it was a 4 point something. So this map shows the Earth's major tectonic plates, and there are 7 major ones and then some smaller ones like the Caribbean plate, the Nazca plate, and this actually tells you whether it's divergent, convergent, or transform. You can see on the bottom of that. All right, so this is your cheat sheet, and I put this on your notes too, I believe. Divergent is 2 roads diverge, they move apart. And what happens here is underneath you have magma that slowly comes up. Okay? This usually isn't violent. You usually have a ridge or a rift, basically an underwater mountain range, and there's lots of volcanic activity here. Okay? Convergent. 2 roads converge, they come together. When you have 2 things coming together, one on one side, one on the other side, what typically happens is one ends up getting subducted, going underneath the other one. Okay, and that's typically what happens in these types of plate boundary. The more dense plate is going to go underneath the less dense plate. And then your transform, think of transformers. As transformers go from cars to robots, their parts slide past each other. Okay. Here, there's no lithosphere that's created nor destroyed. It slides past each other. Topography, there's no major effect. There's no volcanic activity usually here, but there are massive earthquakes, and the most violent type of earthquakes. Divergence, okay, plates slide away from each other. Here, an example, continental divergent boundaries or rift zones. You have Iceland, which is the most famous one, and it is one of the only continental divergent plate boundaries that actually happen above ground. Most of them happen below ground. Okay, and you can see pictures of Iceland. Literally, people are walking on one side, and here's the other side. There's lots of tectonic activity going on underneath. Oceanic divergent plate boundaries is where we get the East Pacific Rise and the Mid-Atlantic Ridge. The Mid-Atlantic Ridge is right over here. Let me do it in a different color. And it is the largest geologic landform. Okay, it basically circles, these rifts circle the globe. Here's another one here, like the ridges on a baseball. Okay, and this is where we get these hydrothermal vents forming. Really cool areas. So what happens along these mid-Atlantic ridges is seafloor spreading. So as magma comes up from the mantle, it forces the plates apart, they move apart, and then as the new rock pools and solidifies, it actually picks up and preserves the direction of the Earth's magnetic field. Okay, and so as these 2 plates are moving apart, you can actually see mirrors. So this is going to be the same as this. This up here is going to be the same as this. Okay, so you have identical features on either side of these mid-Atlantic ridges because of seafloor spreading. And paleomagnetism is preserved within these different layers. Okay, the direction and the magnetism of the Earth has changed over the years. Even now, when the North Pole, magnetic north, is where the North Pole was actually marked. Now, magnetic north now, 50, 60, 70, whatever, however many years later it is actually different. Magnetic north and the North Pole that was marked are actually off a bit already because the magnetism of the Earth goes, the poles reverse every so often, okay, about every million years, and these magnetic bands stay in the crust. So picture it, there's something magnetic in these rocks, and as they're cooling, these magnets line up north-south to what they know as north-south, which may not be the north-south that has now. Hopefully that didn't confuse you. Okay. So convergent plate boundaries, when two plates converge together, okay? When this happens, when there's any sort of oceanic crust, you get deep ocean trenches, subduction zones, earthquakes, mountain ranges, and volcanoes. So as your crust goes down underneath, it creates like chaos right here. And what that does is that forces magma to go up, and that's why you get your volcanoes here. Okay, your oceanic crust is always going to subduct underneath continental crust because your oceanic crust is more dense. Okay, it's thinner and it's way more dense than your continental crust. Okay, at your subduction zones, your denser material is subducted, what I just explained. Okay, so dense, less dense material rises, things go crazy, bam, you get a volcano. So more dense oceanic crusts subducts, you have shallow earthquakes, and you also have deep earthquakes here. Okay, when you have two continents coming together, what happens is one does not subduct underneath the other one, but you basically get massive mountain ranges. And this is how the Himalayan mountains were formed. Few volcanoes form here because the crust is too thick for this magma to actually come up to the surface. Okay, so what you have here is basically two things kind of smushing together. You think of a car, a head-on car accident, the two fronts of the cars crumple, and that's what ends up happening here. Okay, I love this picture. This is an old picture that was taken of the Himalayan mountains, and you can literally see the continental crust crushing and rising up as the tallest mountain range in the world. Okay, so usually you have island arcs that are volcanic when you also have these. Okay, so the Ring of Fire is a ring of subduction zones around the Pacific Ocean. You can see major earthquakes within the past 50 years are along those stars, and then you can see the red are actually the trenches. Okay, so here's a picture that I really like. You see, this is the Aleutian Island chain up here in Alaska, and right next to it you have the deep trench. Okay, this deep dark thing is the trench. So over here you have one plate, and over here you have another plate. Okay, same thing over here, all along Japan. Okay, this is all along the Philippines. I think these are the Philippines down here. But you can actually see, here we go. This is the Philippines over here. And what you have is you have the deepest trench in the world, which is Marianas Trench. So it's deeper than Mount Everest is tall. So this is the height of Mount Everest, almost 30,000 feet, well, 29,000 and very few change. Marianas Trench, if you put Mount Everest into it, you would still have a mile of water left. Okay, it's crazy. So earthquakes on the ocean floor can cause huge waves called tsunamis. These are not tidal waves. They have nothing to do with the tides, which have to do with the gravitational pull of the moon and the sun. So detection of tsunamis is done with buoys in open ocean. Okay, these are the same buoys that monitor the sea surface temperatures for El Nino. Okay, and the biggest tsunamis that we've ever had were December of 2004, the Indian Ocean tsunami. It was a magnitude 9.15 earthquake, which is insane, and 100-foot waves at shore. Okay, so what happened was here you saw the epicenter of the earthquake, and what happened was these waves radiated out from the center, okay, like a drop in a bucket. And the areas that were closest were hit the worst, okay? This western coast of Thailand and Malaysia and the northern end of Sumatra were the ones where you had the most casualties. Okay, so in open water, you really can't detect a tsunami, but when the wave will break, when the wavelength is half of the depth, and so as you come into more shallow water, that's when the wave starts to break, and it's just this massive wall of water, and it's not just one. Okay, usually they come every so often, depends on the magnitude and how far away you are from the epicenter of that earthquake. But it's a series of waves. Your first wave is the biggest, and then the waves behind it are less. In 2011, the Japanese quake and tsunami happened at this convergent ocean-ocean plate boundary, and it happened very close to shore. And that's why Japan was hit really badly. Here was the earthquake epicenter here, and then the area right here got the brunt of that tsunami. Okay, so you could see on this image here, it shows you where the worst part was. Hawaii, okay, over here actually got tsunami waves, but by the time they got there, they were only like 4 feet tall or something. Okay, and here's some images of the destruction and of the actual waves that were coming in. Before and after shot of what was there before and then after the tsunami. Just complete devastation. Right. Transform boundaries. These plates slide past each other, and you can see here the San Andreas Fault is the most famous one, and you see fault line movement after an earthquake. It just basically rips the ground apart, and these earthquakes are very, very violent. Okay? You can see the San Andreas Fault runs through San Francisco and down through Baja. So one day you will have total movement of California away from each other. Earthquake, you have the focus, which is the point of initial movement, and which is deep in the ground. The epicenter is on the surface of the earth, E epicenter. Your Richter scale is what your magnitude is measured by, and it is a logarithmic scale. So a magnitude 5 earthquake is 10 times greater than a magnitude 4 earthquakes. The largest recorded earthquake was a 9.5 in Chile in 1960, which is crazy. Aftershocks are things that quakes come after. Foreshocks are seconds or weeks before the big main shock. Think about cracking your back. You know, you get some little cracks, and then sometimes you get like that big one, and you're like, ah, there it is. Okay. Your primary effects are the shaking. Your secondary effects are rock slides, fires, effects of the actual primary effects. Okay, so here's a bit of a diagram. The focus is underneath, the epicenter is on top of the earth. Okay, so here's your epicenter. Whee! Okay, you have landslides that can occur, you have earth movements, they cause flooding, you have plates that can fracture along the fault line. Earthquake risk in the US on the East Coast is relatively low. West Coast is really, really high. And now there are some other weird areas with earthquake risks. In the central US, from 1973 to August 2015, our earthquakes have exponentially grown in the Midwest, right? And that is actually due to hydrologic fracking. And we'll get more into that later, but essentially humans are now causing earthquakes, which is really freaking scary. Okay, here's now the new earthquake risk in the US. And you can see this area here in the middle, okay, red, now has a lot of issues because of fracking. Also here in Oklahoma, okay, you have issues because of fracking. Whoa! Sorry, not too good with this. World earthquake risk. You can see over here, these are, okay, I can't work this thing, the Himalayan islands. You have all of these areas that are along the Ring of Fire in the Pacific, okay, all along here. And then the Ring of Fire still all along here. You can see where those earthquake risks are. And then here, Greece and Turkey also have huge risks along with the Middle East. Lots and lots of earthquakes lately in the Middle East here. Okay, hotspots are a little bit different. They develop above a stationary plume of magma, and the hotspot stays in the same spot, but as the plates move over it, that hot spot will actually break through the earth in different spots. Okay, these are different volcanic hotspots. Okay, Iceland is a huge hotspot, and along a plate boundary, you have this very famous hotspot, otherwise known as the Hawaiian Islands over here. And then this one over here is the massive caldera in Yosemite National Park, is a massive, massive hotspot. Okay, so Hawaii, you can see here is the hotspot down the bottom. Okay, and this is what we know as Hawaii, but the island chain extends all the way here. Okay, these are old islands from the hotspot all along here. Okay, that have weathered and eroded down back into the ocean. Okay, and there's now a new volcano being formed from the hotspot, Mauna Kea, I believe it is, and that is just southeast of the current Mauna Loa, the big volcano on the main island of Hawaii. All right, here you go. This is the Yellowstone caldera chain. Okay, so there's a big valley of basically the caldera, which is when the volcano explodes and it leaves a big hole behind. Okay, different types of volcanoes. Shield volcano, talked about this, low to the ground, it kind of oozes out. Composite stratovolcanoes and cone and dome volcanoes are very similar. I will never ask you the difference between the two of them, but you do need to know the shield volcano. Okay, and what you have is a caldera, which is the collapsed remains of large volcanoes. This is the island of Santorini, and you can actually see this is the airport over here. And they're saying that Atlantis was on the island of Santorini, and basically this massive, massive volcano blew its top, and then it sank in on itself. Okay, and you can see here remains of what was that island, and it provides absolutely magnificent landscapes. Okay, you can see all of the different layers of volcanic ash and also the different layers of and the different eruptions that happened before this massive one that made this island collapse in on itself. Okay, and that's all we got. Oh, more pictures.